Hello there. So in this video, we'll be solving IGCSE Chemistry Paper 42 from the May-June 2024 session. Let's begin. Question 1. A list of gases is shown. Answer the following questions about these gases. Each gas may be used once, more than once, or not at all. Part A. State one gas which is the main constituent of natural gas. Natural gas is a mixture of hydrocarbons and it consists mainly of methane. Part 2 is responsible for both photochemical smog and acid rain. These are the properties of nitrogen dioxide. Part 3 is unsaturated. Unsaturated means that the compound contains a carbon-carbon double bond, which is a property unique to alkenes. Propene is the only alkene we have in our list. Part 4 has monoatomic particles. Monoatomic particles are elements that exist as single atoms because they have a full outer shell of electrons, so they don't usually form or need to form bonds. This is a property of group 18 elements, and helium is the only group 18 element we have. Part 5 reduces iron 3 oxide in a blast furnace. If you refer to the chemical equation of the extraction of hematite, which is Fe2O3 plus 3 carbon monoxide, which reacts to give 2 iron plus 3 carbon dioxide, we can see that iron 3 oxide loses the oxygen it had in the reactants, which would mean that carbon monoxide is the reducing agent. Part B. Nitrogen dioxide and carbon monoxide are removed from a car exhaust by a catalytic converter. Write the simple equation for this reaction. So nitrogen dioxide reacts with carbon monoxide, which gives nitrogen gas, and carbon monoxide, which are relatively more safe to release to the environment. Now we have to balance this equation. On the left hand side we have 1 nitrogen, while on the right hand side we have 2, so we can put a big 2 right here. Now on the left hand side we have 2 times 2, which is 4, plus 1, a total of 5 oxygens, while on the right hand side we have only 2. So we can put a big 4 here to make a total of 8 oxygens on the right hand side, and we can also put a 4 here to make a total of 8 oxygens on the left hand side as well. And now our equation is balanced. A list of 5 metals is shown. All metals form positive ions. Part 1. Describe how atoms form positive ions. Positive ions are formed when atoms lose or donate electrons, which leaves them with a net positive charge. Part 2. State which of the 5 metals in the list has the greatest tendency to form positive ions. The most reactive metals have the greatest tendency to form positive ions, which means we'll need to refer to the reactivity series for this question. We can list a few of the elements from the reactivity series by using the mnemonic "Please stop calling me a careless zebra" and so on, but we don't need all of them because reactivity increases as you go up the reactivity series, and potassium is the most reactive. It is also present in our list, which means that'll be our answer. Part 3. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. Catalytic properties are something unique to transition metals. In our list, copper, iron, and silver are all transition metals, which means that magnesium and potassium are both valid answers for this question. Part 4. State which of the 5 metals in the list is a major component of stainless steel. Stainless steel is an alloy that consists of iron, chromium, and other metals, but its main component is iron. Part B. A student adds a sample of a metal to an aqueous metal salt in a beaker to see if a displacement reaction takes place. Complete table 2.1 to show the color of the solution in the beaker at the start and at the end of the experiment. In the first experiment, we have magnesium as the metal and iron 2 sulfate as the aqueous solution. So to decide if magnesium will displace iron from iron 2 sulfate, we have to refer to the reactivity series again. If magnesium were more reactive than iron, it would displace iron from its compound. So if we refer to the reactivity series, we can see that magnesium is above iron in the reactivity series, which means that it will displace iron from iron 2 sulfate, and the new compound form would be magnesium sulfate. The color at the start of the reaction is green because iron 2 sulfate is green, but the color at the end of the reaction would be none or colorless because all metal salts from group 1 and group 2 are colorless. For the second experiment, we have silver as the metal and copper 2 sulfate as our compound. If you refer to the reactivity series again, we can see that silver lies below copper, so our compound will remain unchanged. Copper 2 sulfate is blue, so the color at the start of the reaction will be blue, as well as the end of the reaction because the compound remains unchanged. Part C. Most group 2 metals form a gas when placed into cold water. An alkaline solution is also formed. Name the gas formed when strontium is added to cold water. When a metal is added to water, which is the alkaline part of the products, plus hydrogen gas. So the gas that will be formed whenever strontium is added to cold water would be hydrogen. Part 2. Name the alkaline solution formed when strontium is added to cold water. As I mentioned before, the metal hydroxide is the alkaline part, and in this case, it is strontium hydroxide. Part 3. One group 2 metal reacts very slowly when placed into cold water. When heated, the metal reacts with steam to form a white solid. Identify this metal and name the white solid formed. We can refer to the periodic table for this question. And recall that the reactivity of group 2 metals increases as you go down the group, meaning that the elements at the top are the least reactive. Beryllium does not react with steam, meaning that magnesium is the element we're looking for. The metal is magnesium, and the white solid formed will be magnesium oxide. And this is because when a metal reacts with steam, they react to form a metal oxide plus hydrogen gas. Part D. Under certain conditions, iron will react with steam to form an oxide of iron with the formula Fe3O4. Fe3O4 reacts with dilute hydrochloric acid to form a mixture of iron 2 and iron 3 salts and water. Deduce the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid. So we have Fe3O4 plus HCl, which react to give a mixture of Fe2 plus salts and Fe3 plus salts. Whenever a metal compound or a metal reacts with an acid, it displaces the hydrogen ion in the acid compound. So the negative element that will be with Fe2 plus and Fe3 minus will be Cl minus. Fe2 plus and Cl minus will have the formula FeCl2 if we use the cross method. FeCl and Fe3 plus and Cl minus will have the formula FeCl3. And don't forget that water is also formed. Now we just have to balance our equation. I'll start with oxygen. On the left-hand side, we have 4 oxygens, while on the right-hand side, we have 1. So I can put a big 4 here. Now let's balance the hydrogens. On the left-hand side, we only have 1. On the right-hand side, we have 4 times 2, which is 8. So we can put a big 8 here on the left-hand side. And now we just have to balance the irons. On the left hand side we have 3, on the right hand side we have 1 plus 2, to make it a total of 3 irons on both sides. And notice that I put a 2 with this compound and not this compound, because if I put it right here, then the chlorines wouldn't be balanced. So you have to take that into consideration when deciding which compound to put a number with. Question 3. The symbol equation for the industrial production of ammonia is shown. Part A. Name this industrial process. The production of ammonia is also known as the Haber process. A good way to memorize this is by remembering that Haber starts with an H, and the chemical formula for ammonia, which is NH3, also has an H. Part B. State the meaning of delta H. Delta H stands for enthalpy change, which is the energy change in the reaction. If it's positive, it means that it was an endothermic reaction, but if it's negative, like it was here, it means it's an exothermic reaction. Part C. State the typical conditions and name the catalysts used in the production of ammonia. The temperature used is 450 degrees Celsius, the pressure is 200 atm, and the catalyst used is iron. Part D. State 2 methods of increasing the rate of this reaction. To increase the rate of the reaction, we can increase the temperature or the pressure. And this is because when you increase the temperature or when you increase the pressure, more reactant particles collide together, and so more products are formed. Part E. The symbol equation for the reaction can be represented as shown in figure 3.1. Table 3.1 shows some bond energies. Use the bond energies in table 3.1 and delta H to calculate the bond energy of an NH bond in kilojoules per mole. Use the following steps. Calculate the energy needed to break bonds in the reactants. In the reactants, we have a single triple nitrogen bond, which has a total energy of 945. We also have 3 hydrogen-hydrogen bonds, which each have an energy of 435. And since we have 3, we'll multiply that with 3. This gives us a total energy of 2,250 kilojoules per mole. Next, we have to calculate the energy released when bonds are formed in the products. So for this question, we cannot use the same method we just did to calculate the energy needed to break bonds, because we don't know the bond energy of an NH bond. So we can just use enthalpy change along with the energy we just calculated to calculate the total energy released when the products are formed. Enthalpy change is equal to energy needed to break bonds minus the energy released when bonds are formed in the products. We're given enthalpy change at the top of the question as minus 90. So minus 90 is equal to the energy needed to break bonds, which we just calculated as 2,250, minus, we can call the energy we're trying to find X. And X turns out to be 2,340. Next, calculate the energy of an NH bond. So if we refer to figure 3.1 once again, we can see that we have a total of 3 NH bonds here and 3 NH bonds here, meaning we have a total of 6 NH bonds in the products. We also know that the total energy released when the products are formed is equal to 2,340, meaning that the total energy of 6 NH bonds is 2,340. We can use this information to calculate the bond energy of a single NH bond, which would be 2,340 divided by 6, which turns out to be 390. Part F. An incomplete symbol equation for the preparation of ammonia in the laboratory is shown. Complete the symbol equation. So in the reactants, we have calcium oxide, which is a metal oxide, meaning it is basic. And we have an ammonium salt, which contains ammonium ions, which behaves like a weak acid. And the general rule is that whenever ammonium salts react with a base, we get a salt, ammonia, and water. Because this, in a sense, is a neutralization reaction. Part 2. Name NH4Cl. This is ammonium chloride. Part 3. Calculate the volume of ammonia, NH3, measured at room temperature and pressure, which forms when 1.12 grams of calcium oxide is heated with excess ammonia. And we're also given the MR of calcium oxide. To solve this question, we can first calculate the moles for calcium oxide, and then we can use stoichiometry or mole ratio to calculate the actual moles for ammonia. We can then use the number of moles and the molar volume to calculate the volume of ammonia that is formed. So for calcium oxide, the number of moles will be equal to mass over MR. Mass is 1.12 grams, MR is 56. This gives us 0.02 moles. Now if we compare the mole ratio of calcium oxide is to ammonia, by referring to the equation we're given above, we can see that we have this imaginary 1 with calcium oxide, while we have a 2 right here with ammonia. The actual number of moles of calcium oxide is 0.02. The number of moles of ammonia is unknown. You could cross multiply to find x, which will be equal to 0.02 times 2, meaning x is 0.04. And please know that these are the mole ratio, the one we write in equations, while this row is the actual number of moles that we can calculate using mass and MR. So now we know the number of moles of ammonia, which is 0.04. We can calculate the volume by using the formula mole times molar volume, which is 24 decimeter cubed. The moles we have are mole is 0.04 times 24 gives us 0.96 decimeter cubed, because we had decimeter cubed here. But the question wants the answer in centimeter cubed, so we'll multiply this by 8,000 to convert it into centimeter cubed. And so our final answer turns out to be 960.